Alright, so for this, we're integrating pretty much this equation to find the arc length of that. And we know that g of y is this. Sorry. We know what g of y is, and that's supposed to be g prime, so. And basically g prime is y squared plus 1 over 4. It's not plus, it's minus because you're multiplying the negative 1 right here down there. So it's minus 1 4 y to the negative 2 because you're subtracting 1 on top as well. And so that would be g prime. This squared is doing that just to make it easier on me is by just already putting the negative 4 down in the denominator to make it positive. And basically this just makes that's 1 and that's 1, and that makes this is a negative 1 over 2. So we have our integral from 1 to 3, square root of y4 plus 1 over 16 y to the 4th minus 1 over 2 plus 1, that's all under the square root of dy. So because we have a 1 over 2 right here, that cancels out and that makes this positive 1 over 2. And we also want to give this a common denominator, and we have that denominator right there. So we're going to multiply the top and the bottom right here by this, and this will be multiplied by 8y 4, 8y 4. My handwriting's not the best, it's better up here, because I had more time. So we have 1 over 3 times the square root of 16y to the 8th plus 8y to the 4th plus 1. And don't forget the denominator, which is try to fix this. $16y to the 4th. So this equals to, and this is all under the denominator. So now that we have our top and bottom, we can take the square root of the top and the bottom, but first we want to change the numerator. So we have 16y to the 8th plus 8y to the 4th plus 1. To make this easier on us, we're going to make u equal to y squared, and that would make this 16 u to fourth, and sorry, not to the fourth. My dog's being bad. Yeah, no, it's u to the fourth plus 8 u squared plus 1. And if we were to factor this out, this would make it this would be 4 u squared plus 1, which is just basically 4, because that's y squared, that's 4y to the fourth plus 1. And to make it equal to this again, it would be squared. So we have our integral from 1 to 3, the square root of 4y to the fourth plus 1 squared. And that's the top, this numerator, over, we have 16 square root times square root of y to the fourth. And that's dy. This then equals the integral of 1 to 3. So basically, since this would equal 4, we're just going to move that back out, and it's on the denominator, which would make this 1 over 4. And we have u squared over, and this also cancels out. Plus 1. That's dy. And now that we have this all separated, we can make that equal to 1 over 4 of 1 to 3 of 4y squared over y squared dy. That's not right. Y squared over y fourth plus 1 to 3 of 1 over, well, just to make that easier, right? We're just, because it would just be 1 over y squared, we're just going to put y to the negative 2. And since that looks like 4, so we have 1 over 4 of, so I'm going to make a smaller integral, not integral, bracket. My brain isn't working right now. And so these cancel out. We have our y squared, and that would turn into a 2 because it's on the denominator. So we have 4, and I should have moved the 4 to over here. So we have, and I'll do that right now. Four of y squared, so that's plus 1, and so it'll be y over 3 to the third of 1 to 3 plus, and this will be just plus 1 is y to the negative 1, and it would be over a negative 1, so negative 2 plus 1, and that would be 1, 2, 3. It equals 1 over 4 to the, it would be 4 times 27 over 3 minus 1 over 3 plus a negative 1 over 3 minus a negative 1 over 1, which would equal 1 over 4 times 26. And this would be over here. That would be a negative 1 over 3 and plus 3 over 3, which would just equal to 2 over 3. So we'd have our plus 2 over 3 over here. And your final answer should be 53 over 6.